maximum and minimum is basically topic 4.3. Perfect. We learn about absolute extrema, local extrema, then how to find the critical point and how to use the critical point to get absolute extrema over a closed interval. Let's start with 4.3.1, that is absolute extrema. Okay. Consider a function f of x. This function is equals to x squared plus 1 over the interval of minus infinity to positive infinity. So which says that x approaches to positive or negative infinity and f of x equals to infinity. Therefore, the function does not have a largest value. However, since I have to x squared plus 1. Now putting the least value means when x equals to 0. So it would be 0 square plus 1. So my least value for x equals to 0 is 1. Whether my value is negative or positive, let's say it is x equals to negative 1. So it will be negative 1 square. So this square will convert negative to positive always. Negative 1 square, so 1 plus 1 equals to 2. And x equals to 1 also equals to. So my least value will be x square plus 1 at x equals to 0 is 1. So I will write that x square plus 1 is greater than equal to 1. Okay. So we say that this one is the absolute minimum of this function, because absolute minimum means when putting the minimum value of your function, that function variable. So my value is 1, so this will be my absolute minimum, and it occurs at x equals to 0. Then 1 is the absolute minimum of my function with x equals to 0. Now we say that function equals to x squared plus 1 does not have any absolute maximum. So this means that it only has absolute minimum, but no absolute maximum, because it moves to negative to positive infinity at this point. Let's say it is 100. So 100 square plus 1, so that will be answer. And my absolute maximum does not have, my maximum value does not exist, because I don't have limit. So my limit is infinity. So infinity means that there is this function does not have any absolute maximum, but 1 is the absolute minimum of this function. Okay, so to define it, let function f be a function defined over an interval, and c is the member of I. So we say that function has absolute maximum, so that I at c, if by putting this value c is greater than or equals to my function, we say that absolute minimum if function is less than. Let us say that when putting any value, my function is greater than equals to f of x. So it will be absolute maximum. Absolute maximum. My function value of c is less than equals to f of x, it is absolute minimum. Absolute minimum. Okay. So if f has an absolute maximum on let's say my function is I at c, or absolute minimum on I at c, you say that function has an absolute extremum on I at c, that it both have, this function has function c, this my function that f of x having interval I, and let I basically C is the member of I. So this number is basically known as absolute maximum, because both values, absolute maximum and absolute minimum, basically lies on this point. Okay, so this is known as my absolute maximum and absolute minimum points. Okay, now theorem 4.1, that is extreme value theorem. So extreme value theorem is basically if f is continuous function over a closed boundary interval. This means that I have a closed boundary intervals, that there are limit, and there are definite limit, and there is a point in AB at which function has an absolute maximum over, and there's a point in which there is an absolute minimum. So this means that extreme value theorem says that, let's say I have an interval of 5, 7. Let us say this is A and B. Okay. So if this interval has, let's say A at A equals to 5. Okay, A is 5 basically. My value is absolute maximum. My function value is absolute maximum. And for this range, let's say there must a value which is absolute minimum. Absolute minimum. Let's say it is B equals to 7. So if in a continuous function, this is a continuous function which is closed or bounded interval, there's a point. Basically, there are how many points? 2 points. Let's say 5 and 7. 2 points are there. There's a point in my interval AB, which is 5, 7, at function f has absolute maximum. So I will let that 5 it is absolute maximum, and there's a point in my function where function has absolute minimum. I say that it is 7. My function value, let's fx equals to x squared minus 1 or something else. So it has absolute maximum and absolute minimum within this bounded range. Okay, so this is known as, this basically is known as extreme value theorem. Okay, so again, local maximum and local minimum. What is local maximum, local minimum? A function f has a local maximum if there exists an open interval containing such that I is contained in the domain. That it says that f of c is greater than equals to f of x. Likewise, local maxima. So it is local maximum, and again f of c is, if it is less than function value or less than equals to function value, is local minimum. So this is the basically point between local extrema and local minima. Again, for local extrema, let us say my domain is C. So my domain function f of C is greater than equals to f of x. This is known as local maximum. And when my domain value function of f of C is less than equals to f of x, so it will be local minimum. Okay. Let us say that C be an interior point in the domain F. So we say that C is the critical point. So C is the critical point if my f derivative of C equals to 0, that the derivative of my function equals to 0, or f derivative of C is undefined. Is undefined. So this is basically what this is. This is says that my C value is at critical point. Okay, so C value is at critical And for a critical point, my function derivative of c must be equals to 0. This is the first and second function derivative of c is undefined. So these two basically are the cases when my value will be equals to the critical point of the function. Now 4.2 theorem is Fermat theorem. So Fermat theorem is if f has a local extrema at C, local extrema means that it has a local minimum and local maximum. Okay, so it is known as local extremum. So local extremum has 2 points, local minimum and local maximum. Is differentiable at C, so my f derivative of C equals to 0. This is known as that derivative of my function value f of C must be equals to 0. This is known as Fermat's theorem. Fermat's theorem. Okay, now I have locating critical points, and for each of the following, find all the critical points using graphing utility to determine whether the function has local extrema at each of the critical points. So these are f of first value, second, and this is c value. So I have three functions to work with. Let's start with function number 1. So f of x equals to f of x equals to 1 upon 3 x cube, and right here f of x equals to 1 upon 3 x cube and 5 upon 2 x square plus 4x. Okay. So this is the value of x equals to 1 upon 3 x cube minus. First, I have to take the derivative. Okay, let us say that this is my function value. Take the derivative. F derivative of x will be 3 is constant and x cube is 3x squared minus 5.2 is constant, which is x plus 4. Now this value 3 and 3 will be cancelled out, 2 and 2 will be cancelled out, so it will be x squared minus 5x plus 4. This is the value of derivative, f derivative of x. So the derivative, this derivative value is defined for all real number x. Okay. So why all real number x? Because when I put x equals to 0, so x there it will be 0, 0, but there is 4. So at x equals to 4, my least value is 4. So I will say that it is defined at every point. Let us say it is -1. So this x square, this square value will convert negative values to positive values. Okay. So therefore, we only need to find the values of f derivative of x equals to 0. Okay, so I have to differentiate. Now I have to this derivative value, and I say that this derivative value equals to 0. Next step is we have to find the values of x by midterm break or quadratic formula. So it will be x squared minus 5x plus 4 equals to 0. So it will be x squared minus 4x minus x plus 4. So it will be x into x minus 4 minus 1 x minus 4. So this will be x minus 4 into x minus 1 equals to 0. So this means that x minus 4 and x minus 1 equals to 0, so x equals to 4 or x equals to 1. Okay. Now, I have to graph it. So let's say this is my x equals to 1, 2, 3, 4, 5, and 6. So my extreme value, let's say when x, these are basically the critical values. These are known as critical values. So I will write that these are my critical values. Critical values are those values where I have maximum value, whether it is maximum in positive or maximum in negative. Okay, so I have to raise some. Where is it? This part, this part. So I will write that at x equals to 4, at x equals to 4, I will write this as my value for function 3x squared, 2x squared, so this is cube minus plus 4x. I have to put this value that my value is 4, so it will be function of 4, 1 upon 3, x cube will be 4 cube, 5 upon 2, 4 cube plus 4 into 4. Now I have to find it by using calculator. So my first value will be 4 cube, which is equal to 64, and then divided by 3. So it will be 64 divided by 3. That is 64 divided by 3. Next is 5 into 4 squares. So I have to multiply 5 multiplied by 16, then divided by 2. So it is negative 4 plus 4 times, which is 16. So I have to sum my first value is 64 divided by 3 minus 40 plus 16. So my value is negative 8 upon 3. Negative 8 upon 3. So negative 8 upon 3 equals to negative 2.667. Okay. So I will write here at this is, and this is f of 4. So f of 4 is what? F of 4 is so this value is 1, this is 2, and this is 3. So my value, as this is negative I accept, so my value is negative 2.8667. So that x equals to 4. My value is negative this one. So this is basically 4, x equals to 4, and y is equals to negative 2.66. So this is elaborated here. So this is the value. Okay. So this is the upper peak, as when the negative is stated earlier that when there is negative point, so negative point mean it will be some negative values like here. Okay. And what will be second value? X equals to 1. So x equals to 1, I find that 1 upon in function value, okay, here 1 upon x value is 1 cube, 5 upon 2, 1 square, plus 4 into 1. So it will be 1 upon 3 minus 5 upon 2 plus 4. 1 second to calculate. So it will be 1 divided by 3 minus 5 divided by 2 plus 4. So it is 1.833. So it is 1.833. So here it is 1 and then it is, let's say it is 2. So my value will be at x equals to 1. So x is equal to 1. So my value, peak value is 1.8 here. So my peak value is this one. So I will draw a peak value like this one, this one. So this is my graph. So this is basically the evaluation of my graph. Okay. This is for question number part number 1. Now moving toward part number 2, that is x square minus 1 upon 2 whole cube. Okay. So likewise, I have to find the derivative. As the value is what, again, f of x equals to x square minus 1 upon minus 1 whole power, that is cube. So the derivative will be this one. Okay, so and by elaborating it, so this is the 2x multiplied by 3, so it will be 6x. Therefore, function has a critical value. When it says that critical values f of x equals to derivative equals to 0. Okay, so this means that my 6x into x square minus 1 whole square equals to 0. So taking this part to the so to x square minus 1 upon 1 whole square. If take the square under root on both sides, so it will be x square minus 1 equals to 0. So x square equals to 1. So it will be x equals to plus minus 1. Or x equals to 0. So this is the basically point that my value will be 0, my x, or plus minus 1. So from the graph, we can see that the function has a local and absolute minimum at x equals to 0. Let us say I put x equals to 0. So my value of at 0 will be here to 0. This will be 0 and this minus 1 whole square. So it will be only one value. Okay. So at this point, this is sorry f derivative. We have to find it. We have to put in f of x. So f of x value is x square minus 1 upon, yes, f of x equals to x square minus 1 upon, yes, cube. So when this is 0, so it minus 1 cube, so it will be minus 1. So this means that at x equals to this point 0, so this is negative 1. Okay. Now what is positive 1 and negative 1? At positive 1, so it will be 1 minus 1. 1 minus 1 will be what? Will be 0. So it will be 0. So at x equals to 1, my function will be 0. Now the second point, negative 1. So it is negative 1 whole square minus 1 cube. So at x equals to negative 1, this negative 1 square will be 1 minus 1, so it also will be 0. So at positive, it is 0, at negative, it is also 0. So, but does not have any local extrema at x equals to 1 and or x equals to negative 1. So there is no extreme point. Extreme point means that this value must have value greater than 0. Okay, so it doesn't have, it has the value equals to 0. So this means that it don't have local extremum at x equals to 1 or x equals to negative 1, and it has a local minimum value will be negative 1. So at x equals to 0, so we will say that function has absolute or local minimum at x equals to 0. Okay, so this function has three critical points, x equals to 0. Like I said that x first value is this one, x square minus 1 equals to 0. By comparing it is 0. So I will compare that my first value will be 0 and second value will be taken this point that x square minus equals to 1 and then taking under root on both sides. So this is positive 1 and negative 1. The function has local and absolute minimum at x equals to 0, but does not have extrema at other two critical points. Okay. Now for c, my c function is I have to write here f of x equals to 4x divided by 1 plus x. Okay. So first I have to take the derivative by using quotient rule, that the denominator square, then denominator as it is, derivative of first minus derivative of second, and the denominator as it is, so this is simplified. But the derivative is defined everywhere. Therefore, we only need to find the value of x. So I have to differentiate, and differentiate equals to 0. So f derivative of x equals to 0. So my derivative value is 4 minus 4x square divided by 1 plus x square whole square equals to 0. So it will be 4 minus 4x square. This will multiply here, so it is 0. And this will be 4 equals to 4x square. This 4 and 4 will be cancelled out, so x equals to 1. This means that x equals to positive negative 1. So therefore, the critical points are x equals to plus minus 1. So we say that now I have to make a graph for this function. So f of x equals to 4x divided by 1 plus x squared. So I have to find an absolute minimum at x equals to negative 1. Hence function has yes. I have to find the value of at 1 and negative 1 first. So my function value is f of x equals to 4x divided by 1 plus x squared. So I have to put the value of 1. So it will be 4 multiplied by 1 will be 1 and 1 plus 1 will be 2. So it will be 2. So as 1 the value is 2. And minus 1 it will be 4 negative 1 and then 1 plus 1 it will be 2. So it will be negative 2. So it is positive 1 and negative 2 respectively. Positive 2 and negative 2 respectively at x equals to 1 and x equals to negative 1. So this means that I have absolute minimum at this point because the value is negative. So absolute minimum at x equals to negative 1 and absolute maximum as the value is positive. So absolute maximum at x equals to 2. So this is the basically it has 2 point x having x equals to 1 and negative 2, negative 1 respectively, and both for positive value it is absolute maximum and negative it is absolute minimum. Now location of absolute extrema. So let f be a continuous function of a closed interval, bounded interval I. The absolute function of f over I and the absolute minimum of f over I occurs at endpoints of I or at critical points. So location at what? Location will be dependent to things. It depends on first at the endpoints of my function, endpoints of a function value. Let us say it is my domain is 1, 2, 3, 4. So my end values are 1 and 4. It depends on end values. And second is it depends on critical points of function. Critical points. So this is what we can find the location of absolute extrema. Now locating absolute extrema over a closed interval. Let us say a closed, consider a closed continuous function. Okay, so evaluate f at the endpoints. let us say the endpoint is A and B. Find the critical values of A and B by using the solvent and compare all the values found in this A, that is 1 and 2 from location of absolute extrema. The absolute extrema must occur at endpoints or critical points. So therefore, the largest of these values is the absolute extrema or absolute maximum, and the minimum or smallest value is known as absolute minimum. Okay. Now, look at absolute extrema at following intervals with two functions f of x equals to negative x squared plus 3x, and the interval is 1 and 3. So this means that my endpoints are x equals to 1 and x equals to 3. The first thing is I have to find the value at endpoint. So first I have to find the value at 1. So 1 will be negative 1 squared minus 2. So it will be negative 1. So it will be negative 1 square positive 1 minus 2. Okay. So this value will be negative 1. Okay. And x equals to, just give me 1 second. This is basically negative of x square, that is 1 square plus this one. So this value is negative 1. This will be positive 3 and negative 3 plus positive 3 equals to 0. So at function value equals to 1, my value is 0. And at 3, just putting the value, my function value given is minus 2. So the given not, I have to find it. Okay. So I have to find by putting the value x equals to 3 in my f of x. Now, this is the first step. First step is again evaluate the function values at endpoints. So my endpoint in this function is 1 and 3. Now derivate it in second step. So derivation is minus 2 of x plus 3. So this is the derivation. So f derivative is defined at all real values, and there are no critical points where a derivative is undefined. It means to check whether f of x equals to 0. So I have to take it minus x plus 3 equals to 0. So 2x equals to 3 and x equals to 3 upon 2. Okay, 3 upon 2 is in the interval of 1 upon 3. So this is my endpoints, that is 1 and 3. And after the derivation and putting the value equals to 0, my x value is 3 upon 2. So 3 upon 2 will be within my range. 3 upon 2 means 1.5. This means that it's my value started from 1 and ends at 3. So 1.5 is within this range. Okay, so my function 3 upon 2 is a candidate for an absolute extrema. So I have to find the value at f of 3 upon 2. So f of 3 upon 2, what is the value of f of x? This one. So I have to put f of 3 over 2 square minus 2. So this value will be after calculation, it will be 1/4. I calculate by using calculator. So this is 1/4. So this is the function at t/2, which is within my range. So step 3 is at x equals to 0, at x equals to 3/2, at x equals to 3. When x equals to, my function is, as I described, my function is x minus x squared plus 3x minus 2. So at x equals to 0, what is the value of x? At x equals to 3, my value is -2. And when x equals to, there is a slight mistake. It is 1, sorry. At x equals to 1, my value f of x equals to 0, that I find in the previous step number 1. This is basically extreme points 1, 3. So 1 is the end points, 1 point, and this is 3 at 3, it is -2, and applying the midpoint, that by using the formula 3/2, my value of function is 1/4. So 0 means nothing, and there's a positive value and negative value. So positive means maximum point. So positive value will be absolute maximum, and negative value will be my absolute minimum. So from this table, we find that absolute maximum on the interval 1, 3 is 1/4, and it occurs at value x equals to 3/2, and the absolute minimum is -2 at x equals to 2. Okay. Now then we have to make a graph, and by putting all the values, I can make one. First value is what? This is 1. Okay, this is 1 at x equals to 1. Y equals to 1, 0. My first point is 1, 0. This point is 3/2, 1/4. Why? Because f of x equals to y. Okay. So now third is 3 minus 2. These are the 3 points. So I have to put these values in my graph, and this is such like a, you have to make a rough graph just to show all the points for your given function. Okay, now this is function 2, that is f of x equals to x squared minus 3x to the power 2/3 with interval 0 to. So again, you have to find the values on the endpoint at x equals to 0 and x equals to 2. So at x equals to 0, my function is 0, and x equals to 2, it is equals to this point. So that is approximately equals to negative of 0.762. Then I have to derive my formula. So this is the derivation. So after derivation, it must be equals to 0. So this will be here. And after this x, I imply that x equals to negative or positive 0. So like that, this is 2 into x4/3 minus 1 equals to 0, and here it is x4/3 minus 1 equals to 0. After simplification, 2 will be got here, 0 divided by 2 equals to 0. Now, this function value, first value, when there is a power, okay, again, remember when there is a power, so my first value is 0. Okay, so first it is 0. Then I have to put my negative one here, so it will be positive, and taking a fourth root or a cube root, and my value will be plus minus 1. So it is -1 and +1. So the point x equals to 0 is an endpoint. Okay, so we can find the step number 1, but I have to find the value x equals to 1 and x equals to -1. So for x equals to 1, putting the value in function, it is equals to -2 when applying x equals to 1 in my function, and when applying x equals to 2, my value is -0.762. Now I have to compare both values. 3 values. At 0 it is 0, 1 it is -2, and 2 at 2 it is -0.72. Now there must be minimum value is the absolute minimum, and largest value is my absolute maximum. So first there is both values are in negative. So the smallest value is -2, so it will be absolute minimum, and my zero value is absolute maximum in this case. So we compute that for this function 0 to the maximum is 0 at x equals to 0, and minimum is -2 at x equals to 1. Then again, I have to make a graph to plot all the values. So this is the end of the extrema and minimum points. So hope you understand each and every point. Goodbye and Allah Hafiz from this lecture.